Hello. In this video, we're going to be talking about quadratics and vertical motion. Now we have a function that we can use to represent vertical motion that's a quadratic function, and it's h of t equals negative 16t squared plus v sub 0 times t plus h sub 0. In this equation, h of t represents the vertical height of this object at a time t, which is given in seconds. V sub 0 is the initial velocity, and we use the sub 0 because it's the first measured amount, and h sub 0 is the initial height. So basically the initial velocity and the initial height when time is 0. Where is this object going to be? So in our example, a model rocket is launched from a 3-foot platform at a velocity of 72 feet per second. What quadratic function can represent this situation? When will the rocket reach its max height? And what is the height of the rocket at its maximum? So the first thing we can do is start to figure out what goes where. We know the initial velocity is 72. That's in feet per second. We know the initial height, because the rocket starts on this 3-foot platform, is 3. So we just plug these numbers in to create our equation. So we have h of t equals negative 16t squared plus 72t plus 3. And that's the first question, the quadratic that represents the situation. There it is. Next, when will this rocket reach its maximum height? Well, we know the maximum of any parabola will occur at the vertex. So we need to find the vertex of this, which brings up our equation, or our formula, opposite of b over 2a. Now, I'll remind you that a is negative 16, b is 72, and c is 3. So if I do a negative b, that means it's a negative 72. Divided by 2, and a is negative 16, so 2 times negative 16. 2 times negative 16 is a negative 32, and when I put negative 72 divided by negative 32 in my calculator, I get 2.25. So the x-coordinate of the vertex, or in this case the t-coordinate of this vertex, is 2.25, so that would be 2 1/4 seconds. So after 2 1/4 seconds, it'll reach its maximum height. And then question 3, what is that height? Well, now that we know what our t value is, we plug that in. So we're going to do h of 2.25. So we have negative 16 times 2.25 quantity squared plus 72 times 2.25 plus 3. So h of 2.25 equals, if I do 2.25 squared and then take that times negative 16, I get a negative 81. Then I'm going to take 72 times 2.25, and that gets me positive 162 plus 3 more. So then h of 2.25, so at 2.25 seconds, our height is, well, negative 81 plus 162 is a positive 81, plus 3 makes 84. And that's our height of this object, and that's in feet. So this rocket has a maximum height of 84 feet at 2.25 seconds after launch. Okay, so that's us using quadratics to model vertical motion. For now, we're done.